Assalamu alaikum, welcome back friends. In the previous video we discussed about the morphological structural changes in chromosomes. In this video we are going to discuss about the numerical changes in chromosomes. As far as the numerical changes are concerned, where there is a change in number, we have got two types of the numerical change. One is Aneuploidy and second is Hypoploidy. Aneuploidy means when there is variation or change in chromosome number by units only. Just few chromosomes are added upon or lost. However, in case of the Hypoploidy, the entire chromosomal set is lost or added upon, mostly added upon, right? That we call this as Hypoploidy. There is the addition of one complete set. The entire genome is added. That is called the Hypoploidy. We will take that inshallah in the next coming videos. Today here we have to discuss about the Aneuploidy. It is actually the variation in number of chromosomes by units only, addition or loss of one or few chromosomes only, not the whole set. Okay, and this occurs due to the non-disjunction of chromosomes during cell division. So one term is very much new to you, that's non-disjunction. We will discuss it inshallah in the later part of this video. So let's see the different types of this Aneuploidy. Let me rub it off. So yeah guys, we have got the Aneuploidy of two types. One is Hypoploidy. Okay, obviously the second one will be Hyperploidy. You know it, hypo when something is less than the normal thing, and hyper means when something is in excess amount. So Hypoploidy, here there is decrease in chromosome number by units. Just one or few chromosomes are lost, that we call this as Hypoploidy. Got it? Okay. Second thing, we can also say there is a loss of subtraction of few chromosomes. Okay, so Hypoploidy, it can be, the condition can be monosomy, or we can see it's a subtype of it, monosomy. That means when only one chromosome is missing from the entire set, from the entire genome, just one chromosome is missing, that time we call it as monosomy. For example, usually we are having the diploid condition in case of organisms, because diploid condition is one haploid set comes from the fathers and another haploid set comes from the mother. So the attained the genomic condition is diploid condition. So usually we are having the 2n condition, that is diploid condition. Normal this diploid condition, as in case of humans we are 46. It varies in different species. In monosomy we are only just short of one chromosome. That means we have lost only one chromosome here. So one chromosome lost, that means one chromosome is missing. So when the one chromosome is lost, that means the condition will become 2n minus 1. So it is represented by 2n minus 1 condition, because just one chromosome is missing. Okay. Sometimes we can have another condition that's called nullisomy. So in case of nullisomy, we have two chromosomes lost, missing, 2n minus 2. We are discussing the Hypoploidy. Okay, monosomy, nullisomy. So we can have also double monosomy. Double monosomy here. So the condition will be 2n minus 1 minus 1. So we have here nullisomy and we have double monosomy. In both the cases we are losing two chromosomes. Here we lose two chromosomes and here we lose 1 and 2. We are losing two chromosomes. So why there is different terminology, why there is different conditions when we are losing two chromosomes in both cases? I will tell you what the difference. Here in case of nullisomy we are losing two chromosomes, but these two chromosomes which we lose are actually the pair of homologous chromosomes. We are losing the complete homologous one pair. However, in case of double monosomy, we are not losing one homologous pair, but we are losing two chromosomes from two different non-homologous pairs. Okay, let me make it simple. For example, we are having chromosome number 1, we have 2 copies, homologous copy, one will be from father, second one from the mother. We have chromosome number 2, we have got 2 copies, one from father, one from mother. We have chromosome number 3, 2 copies, one from mother. Similarly, in case of double monosomy normal condition, for example, we have 2 copies, one from father, one from mother. 2 copies, 1, 2, 3 chromosomes. Okay. So what happens in case of nullisomy? One complete homologous pair is missing. 2 and minus 2, the complete homologous pair is missing. Then we call it as, when it is the condition is like this, we are losing complete pair. That time we call it as nullisomy. However, in case of double monosomy, we are not losing the complete homologous pair, but we are losing 2 chromosomes from 2 different homologous pairs. For example, we are losing 1 chromosome from here, chromosome 1, it loses 1 copy, chromosome 2, it loses, for example, 1 copy. So 2 chromosomes are lost from 2 non-homologous chromosomes. However, in case of nullisomy, we are losing 1 complete homologous pair. So this is the difference between the nullisomy and monosomy. So sometimes we will be asking the examination, in which type of which is that type of aneuploidy where we are losing the 2 chromosomes, but the 2 chromosomes are homologous chromosomes. We are losing 1 homologous pair. That means it is that time nullisomy. Okay, let's see the examples. So we have this monosomy over here, that means 1 chromosome is lost. Example, you know the Turner syndrome, where the condition is 44x0, that means 1 X chromosome is missing. As usually in normal females we have 44XX condition, okay, but here in case of Turner syndrome we have 44x0, that means 1 X chromosome is lost, 1 X chromosome is missing. We have to discuss it in detail in next video, inshallah. However, in case of nullisomy, so what is the example over here? It is nullisomy is actually the, in case of humans, when 1 complete homologous pair is lost, it becomes lethal. The gamete will not survive, it will not be viable, it will be non-viable, so it will be lethal. And however, in case of plants, it could be possibly found in case of wheat. Even all the 21 types of nullisomics were found by E series in wheat. So we can say simply an example of wheat is over there when we talk about the nullisomy. And we have this double monosomy also, and the double monosomy condition is also found in case of wheat. This is a possibility over there. We can have triple monosomy as well. If we have triple monosomy, that means the condition will be 2n minus 1 minus 1 minus 1 is also found in wheat. Okay, possibly it could be found over there. So then we will talk about the hyperploidy. This was a hypoploidy. So let's talk about the hyperploidy now. Hyperploidy. So dear guys, in case of hyperploidy, the term itself indicates something has increased over here. So what increases? The chromosome number is increased. Increase in chromosome number by units, not the entire set, otherwise the condition will become polyploidy, right? So here we have got the addition of the chromosomes. Addition of the chromosomes is over there, but 1 or few chromosomes are added upon, not the entire set. Okay, so let's see its types. It has got the hyperploidy. It can be trisomy, it can be over here tetrasomy, or the condition can be double trisomy. Okay, so this trisomy, the condition, it will be represented by 2n plus 1, 2n plus 1 condition. That means if 2n is a normal diploid condition, we are having 1 extra chromosome, just 1 chromosome is extra over there, that means the condition is 2n plus 1. In case of tetrasomy, we have about 2 extra chromosomes, 2n plus 2, 2 extra chromosomes are there, that's why we call it as tetrasomy. In case of double monosomy, we have 2n plus 1 condition plus 1, 2n plus 1 plus 1. So in both these cases, what we find, we are having the 2 chromosomes extra, 2, 1 plus 1 is called 2, but we are mentioning it, we are writing it in different ways. We have got different terminologies and different conditions are there for 2 different cases. However, in if somebody asks you how many chromosomes are added upon in case of tetrasomy, you will answer 2. If you are asked how many chromosomes are added upon in case of double trisomy, the answer will be again 2. But where is the difference? You saw the difference in previous case. In case of double monosomy and allosomy, similar type of differences over here. For example, we have chromosome number 1, we have just 2 copies. Chromosome number 2, we have 2 homologous copies. One comes from father, one comes from mother. Chromosome number 3, we have 2 copies. Okay, here we have similarly 1, so 2 copies in 1, 2, 3 chromosomes, homologous pair, normal conditions. In tetrasomy, what happened? For example, 2 chromosomes are added upon a complete homologous pair is added over here. Complete homologous pair is added at chromosome number 1, it becomes the tetrasomic condition. However, for example, the chromosomes which are added upon, 2 chromosomes which are added upon, they are added upon at 2 different non-homologous chromosomes. One is added here, second is added at chromosome number 2, that the condition becomes double trisomy. Okay, so now let's see the examples of them. So trisomy, this trisomy can be autosomal. So this is the portion which we have to deal with, autosomal. That means the trisomy is of autosomes. One extra autosome copy is there, or it can be sex linked, sex related trisomy. Okay, autosomal trisomy, when there is an extra 1 chromosome in there, that's autosome. In case of sex related trisomy, we have 1 extra sex chromosome there. Here we can give the examples as autosomal. We got examples: Down syndrome, due to the trisomy of chromosome number 21st has got 3 copies instead of 2. We have got the Patau's syndrome, the trisomy of chromosome number 13 is here. We have Edwards syndrome, trisomy of 18th chromosome. We have Verkans syndrome, where there is a trisomy of chromosome number 8. Okay, so these are the different examples of the autosomal trisomy. However, when we talk about the sex related trisomy, we have got Klinefelter syndrome. We have the condition as 44 plus XY. Okay, however, usually we have 44XX in females, and in case of males we have 44XY. And we can have Jacob syndrome. In this Jacob syndrome, the condition is 44 plus XYY. Or we can have super female, where we have got the triple X condition, 44 plus XXX. So this is an example of trisomy, sex related trisomy. Okay, let me rub it off so that we can give examples of tetrasomy here. In case of the tetrasomy, examples are, for example, we have here extreme Klinefelter filter syndrome in humans. That means the condition will be 44 plus x y. Okay, this is extreme Klinefelter syndrome. We can have the condition as extreme super female. In this condition we have 4 x's, x 44 plus 4 x's. We can have the extreme male, extreme super male. In extreme super male the condition is 44 plus xxyy. Okay, this is an example of tetrasomy. However, the example of double somy we find it in case of the wheat. It's possibly found over there. Okay, double trisomy. So in the beginning I told you a term that is non-disjunction. Let us discuss what is that.